our plan is between today and tomorrow to talk about secant and cosecant. As I mentioned, secant, cosecant goes specifically along with cosine and sine. Okay, so you have to know which belongs with which. If you are graphing secant, you're immediately going to graph its reciprocal graph first. Same thing with cosecant. So, now, some key points here. Okay, key points right up here. Zeros on the graph of sine and cosine. What do I mean zeros? Well,
the intercepts.
Yeah, zeros on sine and cosine. So places the graph, touches the x-axis, right? Those are going to become asymptotes on secant and cosecant. Okay, so any place there's a zero on sine and cosine, those become asymptotes. And that's why it's going to be so important that we graph sine and cosine first. And then basically, your hills, so like your hills and valleys in sine and cosine, are then going to flip outward and become essentially parabolas between the asymptotes. Okay, so we're going to start with the basic here. Okay, we're going to get a basic draft of each, and then we've got 4 examples to work through between today and tomorrow. Okay? So, secant. What do your brains have to know when I say secant? Secant is the reciprocal of cosine. Okay, so as we go to graph secant, because it is secant, we're going to start off with cosine. So, first thing we're going to do is we're going to just draw a regular cosine graph. Now, it's going to be like a dotted line graph. It's not going to be like drawn in like full lines. Okay, but we're going to draw a cosine graph. Let's see, basic cosine has a period of 0 to 2 pi, right? 2 pi. So we're going to graph 2 pi. I'll leave a little gap, a little space there in case I might go a little bit farther, I guess. Now, what's the middle of 0 and 2 pi? 1 pi. And then you still at least need tick marks, right? Break it into fourths. What's the middle of 0 and pi? Pi over 2. What's the middle of pi and 2 pi? 3 pi over 2, right? Because what are we doing? We've got 1 half, 2 halves, 3 halves, and 4 halves, if you will. I skipped over my vertical axis. Sorry. How high and low do we label on a vertical axis? If there's no amplitude, like that we talk about, change that, the amplitude. A basic cosine graph goes up 1, down 1, right? So now, warning, I would not use your entire vertical axis to go up 1 and down 1. Just an advanced warning. You know, sometimes we want to just put it all the way at the top. I wouldn't recommend that. And I wouldn't, recommend putting it all the way at the bottom. You will see why soon enough. Okay? Now, what I'm going to ask us to do is do a dotted line cosine graph here. So what's cosine do? It starts up, then what? Crosses through pi over 2. Then? Okay. It's low at pi, or a valley. Crosses at 3 pi over 2. Okay, it maxes above 2 pi. Now, I'm not saying mine's perfect, but here's what I need to see you trying to do. Are your highs about the level of 1? Are your lows about the level of -1? Okay, I get it. I can tell right now mine's not perfect, but you will get counted off if it becomes, obviously you just totally forgot to check that. Okay. With this in mind, I think we're going to go, because it's cosine, we're going to go a little bit farther. Just what happens if I go left a little bit here? where would I be going left to? The next mark would be negative pi over 2, and what would my graph do there? It's going to cross through it, yes? I'm looking to get another cross. That's what I'm looking for, okay? We're going to go ahead, let's go a little bit the other way. If we go 1 mark past 2 pi, ooh, what is that?
Yeah, I have it. Oh, I have it.
1/2, 1, 1.5 if you will, 2, so this is,
5.
yeah, it's 2.5, which 2.5 is 5 pi over 2. What are we going to do at 5 pi over 2? We're going to cross through. And again, it's just going a little bit farther. Because remember, these cosine curves, they don't stop, do they? We could go on infinitely. Okay, so there is cosine. Now, next piece. Draw the asymptotes. What becomes asymptotes?
Anywhere we cross through.
Zeros on sine, or in this case, cosine, become asymptotes on secant. So, an asymptote is a vertical invisible line, technically, that we never cross, never touch. So we're going to draw those as dotted lines. So there's an asymptote at negative pi over 2. There's an asymptote at positive pi over 2. An asymptote at 3 pi over 2. And if you went out with me that far, an asymptote at 5 pi over 2.
So then do we just draw the parabolas as well?
Kind of.
Like without touching the asymptotes?
Okay, our next step is to draw the parabolas going outwards. So here's the deal. Your parabola touches the cosine curve either at its peaks or at its valleys. And your parabolas are between, so we're going to have some parabolas that open up, we're going to have some parabolas that open down. And they are between the asymptotes. So right here at this peak at 0, 1, I'm going to have a parabola that opens up. So basically, the bottom of your parabola meets up with the top of the cosine curve. Okay? And then we're going to keep doing the same thing. Okay? Underneath pi, we have a valley here. We have a minimum, right? So that low spot underneath pi is going to cross through. Not sure if there's a point or not. You're not going to have time.
I can do it.
You're not going to get it done.
Okay.
You could try, but he was windy, wasn't he?
He was talker today.
Has every day. Okay. The mountain above 2 pi, what happens? There's going to be a parabola that opens up. Okay? So these mountains, they flip up and they become parabolas that open upwards. These valleys, they flip down, so they become parabolas that open downward. Okay? The base of your parabola touches, can I use the word is tangent to? You guys remember the word tangent to? When two things touch, like they touch at a point and then go their own ways. That's what's happening here. These touch, they don't cross. There's no gap though either. They just touch. That is your secant curve. Okay? Now, I will say, when you graph that on the calculator, if you just graph secant, all you're going to see are the parabolas. Okay? You would also have to graph cosine in there to get that as well.
That's yours? That wasn't you, was it?
It's not me.
Okay, that is what I picked up.
Okay. See, Caitlin is who I was expecting the first time, because I'm sorry, Grace, I forgot about you. You didn't come at the beginning of the period, I forgot about you. Okay. Questions on secant?
Do you always want to have like the 3?
So, technically, what I'll be looking for is more like 2. Now, that will make more sense after we do our cosecant, which is based on sine. But if I want one cycle, right? A cycle goes from 0 to 2 pi. Well, technically with that, what do we have? We have one full parabola down here and 2 half parabolas. So that's kind of the minimum expectation, is the equivalence of 2 parabolas. When we get into some actual examples, I'll share more, but okay. Caitlin, secant will make much more sense after we go through cosecant.
Okay, I don't
Okay.
think I'm gonna even try to.
I would follow along in cosecant, and then you'll be able to go back and figure out secant, I think. Okay? So, let's try cosecant. Now, in order to do cosecant, what do we have to start with? What is the inverse of, or the reciprocal of cosecant? Sine. So you're going to start off by graphing sine. This is not my official graph, so it's just kind of a dotted line graph, right? What do we know about sine? Sine has a period of 0 to 2 pi. So I'm labeling 2 pi. What's the middle of 2 pi? Pi. Middle of 0 and pi is pi over 2. Middle of 1 pi and 2 pi? 3 pi over 2. You've got it. Okay. How high and low does the sine curve go? 1 and -1 now. Same warning I gave last time. Do you see why I said don't use the whole axis for 1 and -1? Because we have to flip those pieces, right? So I try and maybe go about halfway up for my 1, equivalence for my -1. Okay. Can you visualize sine? What's sine do? Sine starts at the origin. And then the first thing it's going to do is it's going to have a max above pi over 2. Then it's going to cross at pi, minimum under 3 pi over 2, and cross at 2 pi. Now, this is not my actual graph. Do not make this a solid line. Do not get in the habit of making that a solid line. It is only there to position my parabolas, and my parabolas are the final graph there. That's the only reason you're seeing this. Okay, so there's sine, yes? Okay. Draw the asymptotes. Well, what do we talk about with asymptotes? Yeah. Any place that is a 0 on sine or cosine, so sine, becomes an asymptote on secant, or in this case, cosecant. So, we cross the x-axis at 0. What's that going to be on my cosecant graph? There's a vertical asymptote on the y-axis. I also cross the x-axis at pi. So there is a asymptote at pi. And I cross the x-axis at 2 pi. So there's a vertical asymptote at 2 pi. Okay, then draw the parabolas going outwards. So in between my first 2 asymptotes, I have a mountain in sine. So what's that going to happen? We're going to flip it up, and it's going to be a parabola opening upward. The vertex of that parabola meets the top of the mountain there, right? Then, between our next 2 asymptotes, pi and 2 pi, there's a valley. A valley is going to flip down, and we're going to have a parabola opening downward. The top of that parabola meets the bottom of that valley. It touches it. And that is cosecant. Now, to address Emma's question earlier, how many are we going to be expected to do? Cosecant is nice and easy to see, isn't it? One period has 2 exact parabolas. Okay? So that's why my rule is always 2. Up here with cosine, if I wouldn't have, you remember we extended an extra pi over 2 on either end, didn't we? So if I wouldn't have extended, it would have been the 1 full parabola and 2 half parabolas. You can draw the 2 half parabolas, or you can make it 3 full parabolas. Okay? So either way there. Now, again, the calculators don't really help you much here, do they? And I don't know, maybe you guys found a way. I was just going to kind of demonstrate real quick. With everything else going on. Because I just kind of want you to see here, if I do, for instance, we just graph cosecant, right? Well, first of all, cosecant is the reciprocal of sine. So in order to graph this on the calculator, I have to do sine of x and then raise to the -1 power. If I just graph that, I'm going to do a z-trig, number 7. Notice, that's the parabolas, isn't it? That's what cosecant is. So that's why the only thing I had to draw a solid line is the parabolas, because that's what cosecant is. Now, if I throw in here a sine x, I can't really do it in dotted line, but notice that sine, it kind of connects them, doesn't it? So for our purposes, graphing by hand, that's why we graph the sine and then put the parabolas in. Okay? I think going back and doing the other one now would make a little bit more sense, Caleb. And just because you've heard the basics. Okay. Let's try an example. Because here's the deal. You've got the basics. Now we've got to throw in amplitude, period changes, center line changes, phase shifts, all that stuff from yesterday. Okay? So let's see if we can get number 1 done. Okay, I'm going to start off listing information. Center line is 1. It is the d value added or subtracted at the end. Amplitude, 5. It is the absolute value of the a value out front. Okay? Speaking of that a value out front, what else do we know? Yeah, there's a negative out there, so that negative says that it is a reflection across the x-axis. Now, at some point we need to discuss. We're graphing cosecant. What do your brains have to connect cosecant to? Sine. A normal sine curve is mountain valley. But what are we doing? We're reflecting, so our sine curve is going to be valley mountain. May look kind of weird, but I'm just trying to give you the visual. Okay, period. Okay, 2 pi over b. B is your coefficient of x, so 2 pi divided by 2 is pi. That is 1 cycle, right? I don't know if you need to still write that in or not, but... And here's the deal. Is some of this stuff memorized now that you've done last night's homework? If not, you can flip back in your chart, right? The other piece, our phase shift. Phase shift is C over B. What's my C over B? Pi over 2, and we're going to be moving to the right because it's a minus sign there, and we're going to go right, opposite of the sign. Okay. Let's see. My center line labels at 1. Yikes. We have an amplitude of 5, but we also don't want to use the whole y-axis, do we? Because we need room to flip. So, how high up are we going up 5? Up 5 from 1 puts us at 6. And I'll be honest, if you don't put 5 tick marks, you just put a tick mark labeling 6, it's fine. It's still there. What if we go 5 down? 5 down from 1 is -4. Okay. We have a period of pi, yes? So, I'm going to put a pi on my number line. That pi, just like what we've been doing, needs to be broken into fourths. So, the middle of 0 and pi is pi over 2. You want the middles of the middles. Whether you label them or not is up to you. Technically, it would be pi over 4 and 3 pi over 4 because it's 1/4, 2/4, 3/4, and 4/4. If you don't label those 1/4 and 3/4, I'm fine. Now, before I start drawing, what's the phase shift I'm eventually going to have to take into account for? Pi over 2. So I'm going to have to move pi over 2 to the right, which means, what's another pi over 2 to the right? 2 more equivalent tick marks, yes? Right? Because each 2 tick marks is pi over 2. So if I try and eyeball this, now, tell me, if this is pi, what is this farthest one out? What is pi over 2 past pi? 3 pi over 2. If you want, let's see, 1/4, 2/4, 3/4, 4/4, 5/4. Again, you don't have to have those in-betweeners labeled. Okay. We need the initial, what am I graphing? Sine with a period of pi. Can you do it? So forget the phase shift right now. We're going from 0 to pi, and we need to put, oh, not just a sine curve though, a reflected sine curve. And here's the deal. I may draw this sine curve multiple times, but I'm not doing my parabolas until I'm done. Okay? So, my reflected sine curve, what's it do? We have to end at pi. So, hit each of your marks. We're going to start at the center. You're going to have a minimum under pi over 4 because it's reflected, yes. We're going to cross at pi over 2. We're going to have a max above 3 pi over 4, and we're going to cross at pi. Mine looks kind of lopsided, but it is what it is. What do we actually have to do, though, with this? We're going to shift it. We're shifting it pi over 2 right. So everything I just did moves to the right 2 tick marks. So instead of starting at 0, I'm starting at pi over 2. My low now is going to be below 3 pi over 4. Cross back through at pi. Max above 5 pi over 4. Cross back through at 3 pi over 2. This is still dotted because is this actually part of my graph? Technically, no. But that is my final sine curve for this problem, yes? So off of my blue, I need to put in what? Asymptotes, which I have 1 at pi over 2, at pi, and 3 pi over 2. And then, now, be careful. Forget my original little light gray thing. My first parabola is going to be upside down. My second parabola is right side up. Okay, I can't take this worksheet out. I have it copied over there. I just don't have it sitting out. If you want to start looking at it, we'll do some more examples tomorrow and maybe get you guys some work time. Okay? So, yeah.
Genius.